students, now in this video let us solve the example on dual simplex method. In previous video we have been seeing when the dual simplex method is applied and the steps to apply that one. So now let me write example. Use dual simplex method to maximize. Use dual simplex method to maximize z equal to minus 3x1 minus 2x2 subject to x1 plus x2 greater equal 1, x1 plus x2 less equal 7, x1 plus 2x2 greater equal 10, x2 less equal 3, x1 x2 greater equal 0, such that x1 x2 greater equal 0. So this is our example and we have to solve this one using dual simplex method. So the step 1 of dual simplex method says us that first of all we have to reduce the given problem into canonical form. Now the canonical form has the objective function must be of maximization type. Now clearly it is of maximization type. So let me write the canonical form is of given LPP is what does it? It will be maximize z equal to minus 3x1 minus 2x2 subject to. Now the constants in canonical form should be of less equal type. Now here this is first constraint, it is x1 plus x2 greater equal 1. So let us make it less equal. So for that we need to multiply throughout by minus 1. So it will become minus x1 minus x2 less equal minus 1. The inequality word changes. Now this is the second constraint and it is of less equal type. So we will keep it as it is. Now the third constraint is again of greater equal type. So multiply throughout by minus 1. So minus x1 minus 2x2 less equal minus 10. Now the fourth constraint is of less equal type, that is x2 less equal 3. Okay. So these are our constraints such that x1 x2 greater equal 0. Now this is our first step. Now the next step we have to find del j in Cj minus Zj, but for that we should find the standard form first of all. So standard form is the standard form of this canonical form. Now here 4 constraints, so and all are of less equal type, so they require the slack variable. So 4 slack variables we need here. So standard form is maximize, and you know the coefficients of slack and surplus variables in objective function are 0, 2x2 plus 0s1 plus 0s2 plus 0s3 plus 0s4 subject to we get minus x1 minus x2 plus s1 equal to minus 1, x1 plus x2 plus s2 equal to 7, then minus x1 minus 2x2 plus s3 equal to minus 10, x2 plus s4 equal to 3, such that x1 x2 s1 s2 s3 s4 all are greater equal 0, and these s1 s2 S3, S4 are which type of variables? Are slack variables. are slack variables. Now this is the standard form. Now clearly from this you can get, when we are going to find the initial basic feasible solution, we will substitute x1 x2 as 0. So here s1 will be minus 1, s2 will be 7, s3 will be minus 10, s4 will be 3. But we know these variables are greater or equal 0, so they won't be, s1 should not be minus 1, s3 should not be minus 10. Means what? Here this LPP has infeasible solution. That's why the dual simplex method is applicable to this. So I must write, therefore given LPP has infeasible solution. Infeasible solution. And why it has infeasible solution? Because here we get, because what? S1 equal to minus 1 and S3 equal to minus 10. So, therefore, the dual simplex method is applicable. Dual simplex method is applicable. Dual simplex method is applicable. So now let us prepare the first table. Now let us see how to solve it using dual simplex method. So now I am preparing a table. Therefore initial simplex table is let us form it. It is different than the previous tables, so let me form it so that you will get it. It is slightly different. So here we have 4 constraints, so 4 rows are required. Now here CB is same, here B and CJ will be same. Okay. Now here we need only XB. Here CB, B, CJ. Here the variables are same, X1, X2, S1, S2, S3 and S4. So now here, suppose we don't want this. Now here let me prepare one column. That one column I required. I won't need 2 columns here. So now here it is simply XB and it is also named as BI, as I taught in the algorithm or steps of dual simplex method. Now here CJ means the same coefficients of those. So it is minus 3, minus 2, 0, 0, 0 and 0. Everything will be same here about. Now here basis has the same variables S1, S2, S3 and S4 and their coefficients are zeros in objective function. Now the first constraint will give us here the minus 1, 1, 0, 0, 0 and here XB will be minus 1. Now the second constraint 1, 1, 0, 1, 0, 0 and here it is 7. Now third constraint will give minus 1, minus 2, 0, 0, 1, 0 and minus 10. Then fourth constraint will give 0, 1, 0, 0, 0, 1, 3. Okay. Now here we need a del j. We have to find del j, that is Cj minus Zj. That is our second step. Now this one we will calculate here using our entries. Now Cj minus Zj. So this is Cj. Now look at here, Zj is what? 0. Here 0 plus 0 plus 0 plus 0. So here Cj minus Zj will be simply minus 3. Here again minus 2 minus these Zj's. So again it is 0. So it is simply minus 2. Now again here what it will be 0. Here also it is 0, 0 and 0. You can see it. Now the dual simplex method tells us that if all del j are less equal 0, all del j should be less equal 0 and bi's are what? Positive. Bi's or simply what can we say? xb or these bi's are positive. Then optimal. Then what? Optimal. But now here this condition is not satisfied. Both should be satisfied. Then it is optimal. If not, it is not optimal. If not, we need to go for next table. So for next table, we need to find pivot element. So pivot row is which row? The most negative xb or bi. Most negative xb or bi will give us the pivot row. So here this is what? A pivot row. This is most negative, I can say. Most negative. Among these negative, it is most negative because they must be positive, then optimal solution. Fine. Now it is most negative. So this is our pivot row. So now let us determine a pivot column. For pivot column, now this pivot row, look at the entries of pivot row. Now here in pivot row, these entries are suppose what we have been named them as aij. Now here, if pivot row have all the entries positive, then problem doesn't have a feasible solution. But if at least one entry, now here two entries are what? Negative. If at least one entry is negative, then we need to find what? Del j upon aij. Del j upon aij, and that gives us the pivot column, and that is what? A smallest ratio. The smallest from this ratio will give us the pivot column, and due to that we get a pivot element. So here let me find del j upon aij. So let us find out del j upon aij, and this one we have to find for those entries from pivot row which are negative. Now here this is minus 3 upon what? Minus 1. So it will be what? 3. This first del j upon aij is what? 3. Similarly this second one, del j is this minus 2 upon again minus 2, and this is what? 1. So for your understanding I have written it as such. Now let me write it directly. This is 3 and this is 1. Fine. Now here this is 0, 0, 1, 0. So here we won't find. It will be found only for those aij are what? Less than 0 of that pivot row. Now which one is minimum among these? Minimum among these is this one. So minimum positive. Minimum positive. So now this is pivot row, this is pivot column. So this is our pivot element. So I must write here I must write that since not all del j less equal 0 and all here bi is what? For positive, or we can observe that thing actually here all del j's are less equal 0 but bi's are not positive. So I must write current solution is not optimal. Current solution is not optimal. Current solution is not optimal. So that implies here squared minus 2 is a pivot element, is a pivot element, is a pivot element. Sorry, which indicates that S3 leaves the basis, S3 leaves, and X2 enters in basis. Therefore, the improved table is. Now the improved table we have to obtain by same previous method, just like a previous method. Here also we have to make this element 1 and corresponding column elements as 0. So the same thing is here. Let me prepare a table. Now this is very small place is left here. So let me prepare it. Some small entries I will write. So you should understand them. Or may I rub this part here? It's better that I will rub this part here so that the table will be bigger. Sorry for that. This is, let me write it, this is minimum positive. So now here let me prepare a table. This is for CB, B, CJ and all. First row, second row, third row, fourth row. Also if required we need 2 more. This last one, if required we need it for ratio. Fine. Now here the first column will be for this is for CB, this is for B and CJ, this is B, CJ, S1, S2 as it is, S3 will be replaced by X2 having coefficient -2, here S4 as it is having coefficients 0, that is CB, here X1, X2, S1, S2, S3 and S4, and here it is what? XB or BI. Fine. Now this one we have to make 1. So for that divide throughout by -2. So we get here 1/2. Sorry, here the coefficients we should write 0, 0, 0 and 0. Now this is 1/2. This is 1, 0, 0. This will become -1/2, 0, and this will become 5. Fine. Now the other these -1, 1 and 1 we have to make 0. So now to make this -1, 0, what we have to do? Simply we will perform an operation. What? We have to perform an operation R1 minus 1/2 R3. Fine. Means we will multiply by half here, and that minus becomes plus, so that it will become 0, and minus half times this R3 means the same one. So let us add these two. So let us add them. -1 plus 1/2 will be -half. This -1 plus 1 will become 0. This will become 1. This is 0. 0 minus half, so -half. 0 plus 0 is 0. And -1 plus 5. So that will become 4. Fine. See again here this 1 and this is also 1. So we have to subtract them. So 1 minus 1/2. So it will be 1/2. Fine. Then 1 minus 1 will be 0. 0 minus 0 will be 0. 1 minus 0 will be 1. 0 minus this minus half will become plus half. Fine. Now 0 minus 0 will be 0. 7 minus 5, so it will become 2. Similarly, now this for this fourth row minus this third one. So 0 minus half, so it will be minus half. 1 minus 1, 0. Then again 0 minus 0, so 0. 0 minus 0, so 0. 0 minus of minus half, so it will be plus half. Again 1 minus 0, so 1. And 3 minus 5, so it will be minus 2. As such we get the elements. Now again look at here, this Bi is what? Negative. So this won't again give the optimal solution. So we need to go for next table. But let us find out what are del J. Del J is Cj minus Zj. So here it will be Cj is what? Minus 3. Now here look at, here 0, this is 0, and the product of these one will become minus 1. So Cj minus 0 plus 0 minus 1 plus again 0. As such we get. Now this minus and this minus will become plus. So here it will be minus 2. It will be what? Minus 2. Now here, look at here, it is minus 2. Next one will be minus 2, minus 2. This is 0. Again this is minus 2. Minus 2 minus 0 plus 0 minus 2 plus 0. So this minus again become plus. So minus 2 plus 2, so that will become 0. Now look at here, this will gives us 0, Cj minus 0, so it is 0. Here this is 0 minus this addition is again 0, so 0. Now this is 0, 0, this will become 1. Look at here, 0 minus, what does it give? Here 0 plus 0 plus 1, and here it is again what? Plus 0. So it will be what? Minus 1. So here we get minus 1. Cj minus Zj. Now again look at here, this is 0 and these are what? Again here it is 0, so it will be 0. So as such we get del J. So now again these all del J's are what? Less equal 0, but Bi is not positive. All Bi's are not positive. So what does it give? It will be not an optimal solution. So let us find out here del J upon Aij. But what are Aij? It's from pivot row. So this is our pivot row. This is most negative. So this is our pivot row. But from pivot row we have to find this ratio only for what? This ratio we have to find only for negative Aij. So minus 2 upon minus 1 by 2. Minus 2 upon minus 1 by 2. So that will become 4. Fine. This one all are positive. So for them we won't find this ratio. Fine. So which one is our pivot column here? So this 4 gives us a pivot column. So here the intersection occurs. So this minus 1 by 2 is our pivot element. Fine. So now here I must write this current solution is not optimal as this one Bi, as not all Bi is greater than 0 or Xb, not all Xb greater than 0. Therefore here squared, what does that entry? Minus half. this minus half is a pivot element. So this tells us that x1 enters in a basis and s4 leaves the basis. x1 enters and s4 leaves the basis. s4 leaves the basis. Therefore, improved table is. What does the improved table we get? Now let us check. Let me add that column if required, that row if required once again. Wait for a minute. So here CB, B, CJ, here x1, x2, s1, s2, s3, s4. Now here one column we required, only one column. So let me rub this part. Okay, so this is what XB or BI. Now this is -3, -2, 0, 0, 0 and 0. Fine. Now here S1 as it is in a basis, S2 also as it is, this x2 is as it is, having the coefficient -2. Now here S4 is replaced by x1, so having the coefficient -3. Fine. And these are having coefficients 0. Now we have to make this -half as 1. So for that, multiply throughout by -2. We get, this will become 1. This is 0, 0, 0, and this is -2 times half, so it will be -1. This is -2, and -2 into -2, so that will become 4. Now these other one we have to make zeros. So now this first one will become 0 by subtracting these two. So -half minus of -half, so it will become 0. Now 0 minus 0, so 0. 1 minus 0, so 1. 0 minus 0, so 0. Now this -half minus half, so it will be -1. 0 minus 1, so -1, and 4 minus of -2, so that will become 6. Now these one we have to add. So adding these two, we get 0. Here 0 plus 0, 0. 0 plus 0, 0. 1 plus 0 is 1. 1 half plus 1 half, so that will become 1. Now 0 plus 1, so it will be 1. And 2 plus -2, so that will become 0. Now the next one, to make this 0, we again need to add them. So adding them, we get 0. Here 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is what again? 0. -half plus half, so it will become 0. 0 plus 1 is 1. And 5 plus -2, so that will become 3. Fine. This is our table. Now here, if you look, all BIs are what? Greater than, not a single BI is less than 0 to go for next table. Now all are greater equal 0. Now let us check what are del J. Del J is what? Cj minus Zj. Cj minus Zj. So here Cj is -3. This is 0, 0, 0, and this is also -3. -3 minus of -3. So that will become 0. Similarly here, this is -2. This is 0, 0, and this is also -2. But minus in between them. So again it is what? 0. This is again 0. Fine. Now the next one, look at here, this is 0. minus, this is what, 0, 0, 0 and 0, so it is 0. Now look at here, this is 0 minus 0, 0, 0, 0, so it is again 0. Now 0 minus, this is 0, 0, 0 and this will become 3, 0 minus 3, so it will be minus 3. Now this is 0 minus Cj, I am taking, this is 0, 0, this is what, minus 2 and this will be plus 6. So minus 2 plus 6, so that will be 4, so it will be minus 4. Fine. Now all del j's are less equal 0, all bi's are positive, since I can write all del j less equal 0 and not a single bi less than 0. So this implies current solution is an optimal basic feasible solution. Optimal basic feasible solution. And what does that solution? Let us find out that. Therefore, we are finding z maximum, and what does the objective function? Minus 3x1 minus 2x2. Z maximum is this, minus 3x1 minus 2x2 is our objective function. Now look at the value of x1 is what? 4 and x2 is what? 3. So here I get minus 3 times this 4 minus 2 times this 3. So it will be minus 12 minus 6. So it will be minus 18. So I must write, therefore z maximum equal to minus 18 at x1 equal to 4 and x2 equal to 3. So this is the dual simplex method. As such we can apply it. Now in next video let us solve one more problem on this method. Okay, thank you.